Hello, and happy Saturday, data science streamers. I'm very excited to be here with you. Whoever's out there or whoever watches this in the future. This is the data science stream. Python and SQL are spoken here, as well as customer churn, which we will spend much time talking about today, I assure you. My name is Carl. I'm a data scientist in Silicon Valley, California. And welcome to my live stream, Carl24K Data Science on Twitch. What is churn? You may be wondering, why do I talk about it so much? Why does this churn thing keep coming up? Churn is subscribers, customers, or users quitting. It's as simple as that. It applies to all products with recurring revenue or repeat users, paid subscriptions, in-app purchase, or ad-supported. So churn is very relevant to Twitch streams with subscribers. So naturally, anyone running a stream wants to keep their subscribers coming back. The origin of the term is from the churn rate, which means the percentage of customers that drop out. And that is very important today because this stream, I'm teaching the churn rate in detail. I think I've talked about churn so many times in so many streams, and now I'm actually going to teach the churn rate. So this will be fun. This might be the first take of me teaching the churn rate, so there might be some rough edges, but we will get through. Hey, MustFit, good morning, welcome. Welcome to Data. Hope you're into churn. Churn is now a verb. You can say the customer churned or I'm churning. And you can also say it like a noun, like make a report of last quarter's churns. Or actually what people really say is give me the churn report for last quarter, I think is what people would say. You can even say I'm a churn. You're a churn, the customer's a churn. Anyway, all this churn talk's probably making everyone crazy. Sorry, it's my thing. But why? Why should you bother to learn churn? I'll just go through all this. For those of you who don't know, I should mention I go through a lot of background at the start of my stream, but there will be code, data, everything, real live code and data coming up. But I give the background for what we're doing here. So why? Why churn? Well, churn is, I would say, the most common data science problem in the world. Every business nowadays is online and has recurring customers, and they have a churn problem. And by studying it here with me, you'll learn special tricks and techniques that you won't learn anywhere else, because I've done a lot of it. Also, I would say this is a great data science for beginners because I'm going to teach like one scenario from end to end. MostFit, there is definitely a chance to talk about my code in specific. My agenda today was Chapter 2 code. But I can talk about anything, with whoever shows up. That's what I like about the stream. I plan something, but then the discussion can go wherever it goes. So just let me know which code you want to get into, and we can do that. And then I'll kind of go back to the regular program, which is Chapter 2. So if you're looking for Chapter 2 code, we will definitely talk about it. But so that's why we study churn. That's why I do it in this stream. And let's see what comes next. What comes next is more background. Fighting churn with data. Why do I keep talking about it? Why do I have this weird picture of a 18th century, farm worker? It's a book. This is my book, Fighting Churn with Data. It actually just came out. Here it is in a paper copy. It's actually a physical book. Let's see, got a question. First thing, you should make use of the env plugin in PyCharm. Oh, maybe I should. I got to take some notes actually, because I'm not an expert at all things Python. That is one area where I could stand to learn a lot. So there's an env plugin, which I guess would make it easier to do those environment variables, which I set up in the settings. Let's see. If we go to PyCharm right now, this will be fun. Where do I get my plugins here? Tools? I'm actually not even sure. The Py package is called .env. Oh, it's a Python package. Plugins. Where do I get them? I thought they always come up down here. Well, I'm actually not going to try to set up... Oh, go to settings. I was going to give up for a second. Actually, it's preferences on Mac, but it should be the same thing. Oh, yeah. Plugins here. Let's see what we can do. env. Let's see. Marketplace. Let's try this. .env file support. End file. Environment variable. So many choices. What were you thinking here? .env support. This one. And so then, now the thing is this actually going to make it easier? Is what I'm not sure of, because now in my instructions, see, I tried to make the instructions simple for new users. And if I added this, then a new user would have to like go to the plugins and install a plugin. And maybe the way I did it was a pain, but at least you do it in the regular settings. But let's see. Oh no, this one, end file. Well, I still want to check it out. But I don't want to restart my IDE and do on... Oh, keep on, it's really easy. All right, you're encouraging me. Okay, do I have to restart my IDE? Let's go. Sure, we'll restart. What the heck? This I don't want to do. Let's see what PyCharm has to say now. Configuration. Look out for it. This is kind of fun. Live configuration. But you know, we do a lot of hacking in data science. It's not all about like the, let's see, about the env tabber. The configuration. I'm actually not so sure about this. You've definitely derailed it in a different direction. But I'm not really sure. I'll get back to the usual programs in a minute. SQL file. I'm just going to ignore that. Well, is this really going to make it easier? So now what do I have to do? See, this is, I don't want to like change my own instructions to use this, because I'm going to then I have to write like new instructions for people to set this up. All right, yes, it's going to be easier. So what do I have to do? In preferences, there's supposed to be... Now where do I get the my env plugins? Not down here. Is it back up here? Do I have to go to the plugins? No, this thing is being stupid. Edit configuration. Oh, in there. Well, that I should know. Edit configurations. Right. Oh, and then now I've got this. I guess this is where you're trying to get me. So just hit environment variables. More missing files. Run configuration. Okay. Yeah, so now does this still make it easier? Let's see, do I need to like look up instructions on this thing? Create an end file at the very root of my folder. Okay. Let's go. New file. Churn.end. How about that? And then do I put the end file, add the end file, and the git ignore? That's always a good idea. I'll take care of git later. In fact, this branch isn't even git tracked. I don't have it committed, so yeah, definitely do that later. So I see. So I could distribute the env file with my code, That might make it easier for people, but they'd still have to go in and edit the name of their database and stuff like that. So now what do I put in here? Just like my environment variables, which I already had in here. Let's see. No. It was actually in the run configurations. Yeah, those are my good old environment variables. Okay. So now we have done the alternate setup. Was this really worth it? Well, we're going to have to see if this works in a few minutes. So are you happy? Can we get back to the regular program now? Well, let's see. I'm going to close this up. And let's get back. For me it was, I switched a lot of the DB. I guess so. I should think about it. I mean, I am always open for learning new tricks. And the truth is, I am constantly learning. Hey, C-Films, welcome back. Yeah, I am constantly learning new things about Python and R and, SQL, all the development environments, everything I use, I'm constantly learning new stuff. And I am always open to learning new ways of doing things. I work with data scientists on my team. Oh, say, C-Films is asking what we're working on today. Today I'm finally working on churn. Once I finish my introduction, it will actually be a churn calculation. So let me carry on just to get up to like the main presentation. I'll finish saying my book is out. There's a discount code, right? 40% off if you want to get a copy of this book or an ebook copy. But you don't need the book. You can also just get the code. So the book is based on my experience, I like to tell people, at a company called Zora, where we calculate churn for many different businesses, but you've never heard of Zora. So this is the background. And what do we try to do about churn is we're trying to reduce it. And so the goal will be to reduce churn by taking actions like improving your product, remarketing or engaging with your customers by whatever channels you can, giving support and customer success training to your customers, and lastly, adjusting your sales and pricing. So that's what we're trying to do in the long run. That's like the overall context here. And last week I did a bunch of setup, and I should have actually put this up when we were having the setup discussion. Mostfit and you had to do all these steps here. You clone a repo, you need Postgres and PyCharm to do this, create schemas, set up Python, and then you do a data simulation, which was like my last week's stream. So if you did all this, you would have a bunch of data in your database that we can look at. Let's see, what programming language are you using to display and use data from a database to a website? Now that's actually a question I'm not a good person to answer because I don't really display data on a website. I mostly display data to business users and people in a company who need to work with the data. And I've never really put data on a website. Cool. Well, if you do a branch of the code that works with a different SQL version, that would be really interesting. Maybe we could make it an option in the repo. But anyway, let me carry on. I don't want to get too sidetracked on the discussion. Let's look at some of the data. So last week we created some data, and I want to show you the data that we've got, just so you know what we're going to be using. So I have a schema here. I don't know if this is big enough to see, but there is a subscription table, and it has these subscriptions. They all have start date and end date and customer IDs. And so if you look in this column here for account, each account can have more than one subscription, but they don't have overlapping dates. So this subscription goes from Jan 5th to February 5th. This one is February 5th to March 5th, etc. And then you've got more accounts in here. And when the subscriptions run out, of course, that's a churn. Okay, C films, PHP and SQL. I know nothing about PHP and like doing websites, so I'm like the last person you want to ask about that. But if anyone does, please have at it. So this is the subscription data that we created last week in the simulation. There's also a bunch of data in an event table, because these are the events that the customers had to using the product. And the product is a social network simulation. Looks like this query is taking a little while. So events also have an account ID and a time, and there's different types of events. So let me try to do a quick SQL to show you what the different event types are. Let's see, do a new query. This is like from my old stream. Let's see, let's just do select event type ID count star from event group. I can't type today. By event type ID. And this will just be a quick summary of the events, if I've got it. Okay, event type, okay, I need to specify my schema, I guess. It's socialnet _ 1 dot event. Okay, and so we'll see all the events that were created by simulation in the previous streams, except we don't have the names. Okay, there's also an event type table. So let's just do an inner join socialnet 1 dot event type on, let's see, let me put in some letters here, T on E dot event type equals, let's see, is this it? I think this needs to be event type ID. Oh, it's ambiguous. Right. Actually, see, now what we want to do is select the event name and group by the event name. And then we should get like a nice summary of these events. Let's see, event type name. Whoops, missed it there too. Well, I should have really prepared this SQL in advance. Next time. See, like I said, this is the first time I've done this stream, so we'll make a few mistakes, but this query is now working. So now you can see the events that are actually in this simulated social network product. There's ad views. People can like and dislike. It appears that they like a lot more than dislike. They message, they have new friends, they unfriends, posts, and replies. And in my last stream, I showed all about how this data is generated through a simulation that includes the customer's satisfaction and frustration by using the social network. So that's the underlying data that was created last week, and that is what we're going to use for the churn calculation today. So that's the data that we've got. Remember, events and subscriptions. Today we're just going to be we're going to work with both. Yeah, I was going to say mostly subscription. So first, let me actually explain the concept of churn. This is actually the first time I've really gone into what churn means on this stream. And it's shown here in a diagram before we get to the code. So if you imagine one of these circles is the customers or subscribers to a service, and the size of the circle is basically how many customers you got or how much money they're paying you. And then time passes. Well, I say start customers, and it could be the money or the number of customers, and churn is basically the same. Time passes, and what happens is you'll acquire some new customers, shown at the bottom. You retain some of your old customers, and then you lose some, and those are the churns. So this little crescent at the top, those are like the customers that you left behind. And the reason they call it churn is actually kind of illustrated by this, because you're constantly acquiring and churning out customers. So you have like a turnover of your customers, and that's why it comes from the term churn. So this is the concept I wanted to illustrate first, and this is, you can find this diagram in chapter 2 of the book if you want to. And then the important other things to note about churn is if you look at the top circle, right? And you think about just what happens to the customers that are in this top circle, which is like your customers at one point in time. Some of them churn and some of them are retained, and those are the only two choices. So churn plus retention as percentages have to add up to 100%. So, and you can turn that around and say retention is 100% minus churn, or churn is 100% minus retention. And so these are important relationships between churn and retention, which shows that you can always use either churn or retention, and it doesn't matter. It's basically a glass half empty, half full kind of thing. So this is the key concepts behind churn. Any questions about something other than programming languages? All right, well, I'll keep going about churn. And actually, I think what's next is a simple, now I'm going to tell you the plan. This is what we're going to do in the rest of this chapter and this stream, and probably my next stream too. I honestly don't think I'm going to get through all this code in one stream, because I got other stuff to do this weekend. You probably do too. But anyway, so first we're going to do a churn calculation which is retention, or net retention. And you'll see why that is called that in a few minutes. And then we're going to do other types of churn calculations. We're going to do the standard customer churn calculation. Then we're going to do revenue churn and activity churn. And finally, time period conversion of churn. And these are all different code listings that we're going to go through. So I just wanted to give like the overview. This is where this stream will go, and probably I'm expecting into my next stream too. This just seems like too much for one stream. So let's see. Let's talk next about net retention. First, by looking at a toy problem. Now, net retention means the net value that was retained divided by the value that you started with. So it's actually based on money. So going back to this diagram, it's the retention part shown in the middle, and it's in dollars. So this is about the amount of money. So in this problem, I'm going to show you some of the intricacies of this with a very simple toy problem. You have 5 customers starting like in January, and then in February you've got a new situation. So this is your time passing. Now suppose one customer churns. Well, also in this example we've got standard and premier plans. So customers pay different amounts, and this is important for net retention. So because it's based on the amount they pay, not simply the number of customers. So suppose one customer churns. That's customer 2. That's the X here. And then also in the month, one customer upgrades from standard plan to premier plan. And then also you add 2 new customers, 6 and 7, shown at the bottom. Now, the net retention calculation, which I'm showing down here at the bottom, is the revenue retained divided by the revenue that you had at the start. So that's, again, just back up to this. The revenue retention rate is the revenue that you retain divided by what you had at the start, which is the top circle. So now, in this case, we retained 79.96 out of our total 89.95 at the start. Why? We lost 29.99 from customer 2 churning, but we gained, 20 a month from customer 5 upgrading in this example. So in this example, the net retention rate is 79.96 divided by 89.95, or 89%. And so that's a simple net retention. Now there's a few things I wanted to point out about this. One, before we go to the code will be next. One is that upgrades matter in this calculation. So the upgrade from $9.99 to $29.99 by customer 5 counted. And also the new customers you add don't count. And that's actually true for all churn calculations. The customers you add don't count for churn. So let's see. Let's look at the code now. So all the code that we're going to look at in this stream and all my streams is on this GitHub repo, github.com, carl24k/fightchurn. And we're going to look at listing 2.1. That means it's chapter 2, listing 1. And I think I haven't actually figured out what I'm going to do, actually. What I'm going to do is I'm going to make a run configuration to run chapter 2, listing 1. Let's see. And if you haven't seen the code from my book, it comes with this wrapper program so that you can run every listing. And this is actually the first time I set it up on the stream. I'm just going to have to go through this real quick. So I'm going to duplicate my old listing, or my old configuration, and then I'm going to go and change the script to, let's see, if you go in the code from the GitHub repo, there's a folder listings. Go in there, then in the Py folder, creatively named, there's run churn listing, which is the basic listing runner for the book. I should actually go to it because I changed the name of my schema from the default, and it'll be a lot easier if I just adjust this. But I have to add it, so I can add the schema as a argument. Let's do that. So I'm gonna go, and these are actually all the arguments. So now I'm going to set the arguments. This is the next thing you have to do to use the code, the wrapper program that comes with the book. So I'm going to go back to my configuration. I'm going to call this run. Well, first, let's just get in that parameter. Schema. I actually renamed my schema to socialnet_1. I've actually got another _2 as well, which is another version. And then I'm going to do chapter 2 listing 1. I forget if I have to give the full text of these. Let's look here. So yeah, chapter listing. So these are the arguments for the script. And you can also run this script from the command line if you want to. Those are the two ways to run it that I have in the book, is in PyCharm, or any IDE would basically be the same, or from the command line. And in principle, you should be able to do this with notebooks, but I'm not a notebook expert, so I have not set it up in a notebook. So let's see, I think I'm almost ready to run, but I want to put some breakpoints in to hopefully show people, how this works. So I've got a method this listing is a SQL listing, and I'll actually show it to you in one sec. So I'm going to put a breakpoint in the function that runs a SQL listing. And now I'll go back out to the project and open up the code. So this will be the first time we look at the code for net retention. Sorry about all that setup, but I had to do it. And I didn't do it before the stream, so sorry. So now this is the net retention code. Let's just go back here for a minute and say what we're trying to do. So we want to figure out all the customers that stayed and how much money they pay us at the end of the period. Going back, to this diagram and this toy problem. Now, what's a great way to do that? Hello, doesn't this look like an inner join? If you just consider that your customers on the left is one table of customers, and your customers on the right is another table of customers, then it's really just a simple inner join in SQL to see which customer stays. Actually, we will do outer joins, MostFit, and you are quite right that outer joins are important, but we're doing retention. You're actually totally pre-guessing. You're way ahead in the stream. That's coming later. And this is retention. Whoops. I'm really getting ahead. This is retention. So what we're going to do is an inner join. Now, how do I get those start and end accounts? I actually select them from my subscription table. So that's what's shown here. This is my first subquery or common table expression, where I do select account ID and the total that they pay, which is called MRR. That's short for monthly recurring revenue in the business. I should have mentioned that in the slide, but MRR is short for monthly recurring revenue. So we select all the accounts and their total MRR at the start of the time that we're measuring churn for. MRR could be in any unit, is typically the home currency of that's selling the product. It could be the home currency of the customer. Now, MRR is monthly recurring revenue, so it's like $9.99. It's basically just what everyone's paying. And for the social network simulation, I do believe it's all $9.99. So we figure out who's active by looking if their start date is before the calculation date And the subscriptions, remember, have start and end dates. Let's go back real quick. So now we're really using the subscriptions that we looked at here. So every subscription has a start and end date, and you can tell if a customer is active on a given date by if that date is before the start date of their subscription, and the end date should be after the end of their subscription. Now, there's a few little subtleties in here, which is why am I using a group by? Now, that's actually because customers could have more than one subscription in this framework. And in many real scenarios, customers do have more than one subscription. In fact, for my case studies in the book, the real data case studies often have more than one subscription. And the additional subscriptions are like add-ons or upgrades or extras. So a lot of subscription companies don't just sell one subscription, they sell multiple subscriptions. So this is for the case where customers have multiple subscriptions, and that's why we do the group buy. So let's see, those are the main things. So this will give us the start accounts. I should mention also that I set the start date and end date at the top for the churn calculation. And this is just for me, I consider it a more clear way to parameterize the whole SQL. So I'm going to select the end accounts in exactly the same way, but using the end date from my date range. And then the retained accounts, this is actually, the key to it is the inner join. So you want retained accounts, it's inner join between start accounts and end accounts on the account ID. And this also tells us the retained MRR, because I'm summing the MRR at the end here. And then the rest of this is the calculation of the net retention. I do these are kind of just extra for clarity. The start MRR is the sum. You know what I should really do? We should actually do this SQL live, in pieces. Let me actually try running the SQL from the wrapper program. We'll see if it works. And then we can take it in pieces and go to the SQL tool and look at it. If it's not too boring, we'll see. You guys can tell me if this gets boring. Well, let me try running the listing and stopping at my breakpoint in the wrapper program. See if this works. Cross fingers. I was messing around with the environment variables. Oh, no parameters. Listing social net will run. Oh, I think I didn't rename my parameter file. That's the problem. Sorry, hack in here. I renamed my schema, but I have to. All the listings in this for the book are parameterized, so you can run these on different schemas. And in fact, I did this while I was creating the book. I was running all this code on 4 different schemas, 1 for the simulation and 3 for my case studies. So what I have to do is just rename this to match. Is there a rename here? Maybe I should just save as. Let's see. I can show you these configurations more in a minute. Let me just get things working first. This now will be socialnet _1 listings. So each one of these JSONs has the configuration. In fact, you can see right here, this is how I configure listing 1, chapter 2. These are the default start and end date, and the only parameter for listing 1 is the name of the code. So let's see if I can run my code again now that I renamed the listing configuration. Okay, here we go. I'm in the wrapper program now, and all this is really going to do is load my SQL query from the file. You can actually see, let's see. This is the path to the listings, chapter, the number, and then the name of the listing. I'm going to connect to my database, which apparently works. I add the search path to my SQL. That's just like a convenience so that it's not in all the SQLs. The search path tells it, what schema to run against. And then I'm going to plug in the parameters, because you might have noticed, this is back to the SQL. Sorry, I just jumped like that. In the SQL, I actually have bind variables that start with a %, and that's so I can plug in the parameters and run the same SQL on different configurations. Let's see, so I was back in the, Not this one. I was in, not, here, I was in this one, I guess. Okay, so I'm in run churn listing. So here's the SQL. Now is where I put in the bind variable. So I'm just going to put another breakpoint here after it prints the SQL. So it just went through and it printed out the SQL, should have, on the console. That's really what I wanted. And what it's done for me is it's put in my search path, it's plugged in my bind variables. And now we can actually try, some piece of this query is what I wanted to do with a little copy pasting here. I'm going to take this over to my Postgres friendly little SQL program. And let's just try this. Let's do... So this is just the part which selects the start accounts. And now you can see it's going to select accounts where they start before or after, this date range. So this is like selecting star from start accounts. Let's just try it. Whoops, need a from state word there. Let's see, subscriptions. Hey, I thought I set a search path. What is my error here? Subscription. I think I might just need to set the search path first. Doesn't this work? Let's just try this. Sorry, live hacking here. Alright, now I've set my search path, and hopefully it won't bug me about that again. Let's see, let's go back to get the rest of the query that I really wanted. So this is the rest of the query that we're trying to run. We will hopefully select the start accounts now. I'm trying to actually just find a good way to talk people through. Looks like Postgres specific SQL. Well, it is specific to Postgres in a few respects, yes, no doubt. Definitely in setting search path, and let's see, this is Postgres specific, the casting, but it should be pretty easy to convert this into, oh God, I am completely failing here. It's not even working. Date range. Oh, I lost my with statement. That's the problem. So I'm using common table expressions. All right, finally, I successfully ran the SQL. That was pretty painful. So it's Postgres specific in using, it's not, common table expressions are not Postgres specific, but they are relatively recent. So if you're using an older MySQL or something, it won't support the common table expressions, which is this syntax for subqueries. And so let's see. The rest of this is not really that Postgres specific. Only this casting notation is Postgres specific, but it's pretty nice and concise. So let's see. So now I've done this SQL which selected all my start accounts. I mean, you can't see the little text at the bottom, but it said 10,153 rows. So these are all my accounts that were active on 2020-03-01. And that is the first part of the SQL. And if we go in, should be able to now hopefully more gracefully add these other parts. And this will give me the end accounts in a similar way. And I need to put a comma here. And so this is the common table expression for the end accounts. And let's see, select star from end accounts. You can see each different part of the SQL coming out here. Now I've got 10,567 rows, but they look pretty similar actually. We could even order them, but not that interesting. So then the rest of the SQL, if I put it in, the retained accounts, I put this block in, I will get, let's get the retained accounts. Maybe I'll just do count star. That'll actually be more easier for you guys to read. Okay, 9466 retained accounts. some. So you can see how with an inner join, I am finding out how many accounts stay and the total amount of money that they paid. And that's not too hard. So then for the rest of this SQL, I'm actually going to, like I said, I'm just going to select the starting and ending MRR and then select out the component. So I'm just going to put in the rest of the finished SQL now into Postgres, and we can look at each part. So these are simple aggregations on the start accounts and the end accounts, total MRR and total MRR for both one. I could have done that in the final select, but I felt like it's easier just to read the whole thing, in pieces like this. So let's see if this works. Oh, another typo. Probably, what am I missing? Syntax error at or near total MRR. Oh God, this is not a very helpful error message. What did I mess up now? Not very helpful error messages from databases. Don't you think? Every database I've ever worked with, can you please show the date range line again? Yes, the date range line is actually just a pair of constants. I should put it on 2 lines. This is just my hard-coded constants at the start. I'm just picking one date as the start date for my churn calculation and one date as the end date. And then I join with this. It's not really a range, it's just like the start and end date. Let's see. Now, why am I getting this error? I just want to copy paste the whole thing in. Now it doesn't now it's giving me an error on. I don't know. Oh, maybe it doesn't like putting that on another line. Yeah. Okay. Retain MRR does not exist. What is going on with this now? This is really weird because this SQL works when I run it against the database. Let's go through in the debugger and see if it works. If it doesn't work, then I'll know something's really wrong. So right now, I'm at this line in the debugger where I've created my SQL, and I'm pretty much now just going to run it against the database. So I'm just going to hit the Go button, and it prints out start MRR, retain MRR. Yeah, it says the retention rate and the churn rate. So this works. I might have just put a typo into the SQL when I transferred it. These things always happen. I'm going to recopy the whole thing, put it in here. Oh, it looks like I was missing the from clause. That was my error. Alright, so here's running the whole thing. See, it really does work. So the first thing it calculates is the retention rate. The number of decimal places is really annoying here. Oh my god, it's got to show us every single decimal place. That is super annoying. But you can see the net retention rate is around 93% in this case. And now, how do we also do the churn rate? Remember, retention is 100 minus churn, or churn is 100 minus retention. Back from this slide, right? Because, whoops, hey, sorry about that, making you dizzy. So from this slide, churn and retention have to add up to 1, and now I'm going to use that fact because I've calculated retention. I can calculate the churn as just 1 minus the retention. So back to the output here. So the retention rate, or the churn rate, is just 1 minus the retention rate. Here's the line that worked on my site. Select 20 date as start date, 26 as end date. Is that, and what did I use here? Well, whoops, sorry. Looks like that works. Still think this one, whoa. My environment's kind of freezing here. I think I've crashed my Postgres thing. That's new. Postgres, come back to me. Alright, I think I'm going to have to do the force quit here. Sorry, people. I somehow crashed it. Let's get a new post-it going. Let's see. Now my keyboard's bugging me. Man, this stream is going to hell. Please bear with me, people. These are some live issues. Here we go. Don't know what really happened. Okay, now it's right back where it was, saying here. I probably have to go back and set my path again. Remember that? There we go. Set the search path, SocialNet 1. I've reset it. I'll go back to the last version of the query that I was trying to run right here before it crashed on me. All right, so back here's the result again. Little recovery from my dying Postgres GUI there. So back to how the query works. So this is your retention. It's the retained MRR divided by the start MRR. And then the churn rate, like I was trying to say, is 1 minus that ratio. And then I'm also just printing out here the start revenue and the end revenue too. And so that basically beats to death the code for the net retention SQL. So here you can see the retained MRR is less than the starting MRR, and so that's why the retention rate is less than 1, which makes sense from the diagram we looked at before. Okay, so like I said, that pretty much beats to death the net retention SQL. So let's say a little bit more about the concepts related to net retention. Remember, this was our toy problem example. Now I've looked at the code. Now I want to talk a little bit about the uses of net retention before we go on to another churn rate, because you're probably wondering, like, why are we talking about 4 different churn rates? Why are there so many? Well, they do have different applications. Why net retention? Number one is it's simple. That was like the simplest churn calculation you could do by using an inner join to find the retention. Now, it's simple, but it works great if all customers pay only one price for your product. Like if everyone paid $9.99, then the churn would be 100% minus net retention, and that would be a good churn definition. Now, the problem with net retention is actually that if there are multiple prices, upsells cancel churns. And that's actually what I showed you back in the toy problem. Remember, we had one churn for $30, $29.99, and one upsell, which added, and that is a real thing in net retention in real companies. So it's kind of a distortion of your churn rate to offset the churn with your upsells. Now that's bad for churn fighting because it just kind of like obscures your view of churn. You kind of have like a rosier view of your churn because you have offset it with net retention. Now it's actually good for what? It's good for investors, or anytime you want to show the glass half full of your churn, or kind of like putting a positive spin on your churn, that's when people use net retention because it sounds better. Your net retention is, if you have multiple prices, remember, if there's only one price, your net retention is going to be exactly the same as the regular retention or churn. So churn from net retention is the same as regular churn whenever you have only a single price. Or if you have no price. What would happen if you had no price and all your customers didn't pay you? You could go back to the net retention SQL and modify it so that instead of doing the sum of MRR, you just did count distinct, account ID or count star. Count distinct star because you don't want to count the subscriptions. So you actually want to do count distinct account ID instead of sum MRR. And if you did that for both the start accounts and end accounts, then this would also be a great calculation of your churn and your retention using an inner join. So that is what net retention is good for, either if you have only a single price or if you have no price, it's a free product, you can use it. Or if you have multiple prices and you want to make a rosier picture of your scenario, you can use net retention to basically cancel some of your churn with your upsell. And then the numbers will sound better for outside investors. And you will find, if you look in the corporate statements, companies that report churn, they're generally going to report net retention because it's kind of like the best sounding churn metric to report. And also just reporting retention, it's like glass half full thinking. Generally, your churn is a small number, like say 5 or 10%, and your retention is a high number, so 90% or 95%. It just sounds better to report retention because you put the positive, emphasis on the positive. All right, so that's what you do with net retention. Now, the weakness of net retention, I should mention again, is that if you're trying to understand your churn, the upsell canceling the churn kind of distorts things. So that's why we get to the next measurement of churn, which is the most common or the standard customer churn. And it is actually just based on the count of your customers instead of on the dollar value. So here's a simple regular churn toy problem. And actually, this is kind of it seems simpler than net retention because there's no money involved. This is another, kind of simple example. Suppose you have these 5 customers in January. And in the month of January, one of them cancels. That's customer 2. So these are your customers in February. And also you add 2 new customers, suppose, hypothetically, because you're a growing business, you're a successful stream, you're getting more customers all the time. So then you would calculate the churn rate as the number who churned divided by the number at the start, which in this case is 1 divided by 5, or 20%. So 20% churn rate. And once again, in this case, the number who you added are not relevant. These 2 new customers, the plus signs, they don't enter into churn. Because again, going back to going back to the Venn diagram, churn is about who left relative to who you had at the start. And you don't include the acquisition. Why? Because it's just another department. So we eliminate upsells and downsells in regular churn, basically just by ignoring them. And you can use this metric whenever it's appropriate. And that is appropriate basically when you just want to understand how many people are churning and when your upsells and downsells are kind of not that big amounts of money, really, is the way to put it. I'll say more about exactly when you would use it. But first, let's talk about the joins. So, MOSFET, you were asking about outer joins before. We're going to get into outer joins right now to do a direct churn measurement without using retention. So retention, I said before, is like an inner join because you take the start customers and join them with the end customers and see who's in both. Those are your retained customers. Now, if you actually want to calculate churn directly, that's when you use an outer join. This is why I said you were like getting ahead of the stream, by asking about, inner and outer join before I was ready for it. So now to find the churn customers and do it directly, you actually use an outer join. And that's what we're about to do in the next SQL segment. So you take the start customers and do a left outer join on the end customers. Now, what's an outer join for anyone who doesn't know this already? I expect some of you already do because it seems like a pretty data literate crowd. But what an outer join does is it takes all of the rows in one table and then tries to add the rows in another table. But if it doesn't find a match, it still keeps them. An inner join only keeps all of the I believe a left join equals a left outer join. So an inner join only keeps the matching rows. A left outer join keeps all the rows in the first table. And that's appropriate here for churn because, it's actually this first step. We keep all the rows in the left table, and then if they match a row in the right table, we'll take that's the end table, will take the data. Now, how do we find the churns is actually by adding this where clause at the end of the outer join. That's where you find the rows that were in your first table but not in the second table. And that's basically the outer join trick for finding churns. And the key is the where clause. And so we'll go look at the actual SQL next. I will just mention, if you're interested in finding the newly added accounts, the acquisition customers, you're right in thinking that that would be a right outer join. If you have it depends, of course, what's left and what's right depends on the order that you list your tables in the SQL statement. But if you imagine that your start customers are the first table, your ending customers are the next table, the acquisitions would be a right outer join. But again, you use the same trick on the account ID that you do the join and then you look for those that have null in the other tables matched. So you look for rows that don't match. All right, I think ready to go to SQL. Now this is also in chapter 2, because chapter 2 is basically like the churn rate chapter. Chapter 2, listing 2, let's go open it up first and just like eyeball the code before we start running it. So once again, I select a start and end date just by, kind of putting in bind variables in a separate little CTE at the start. And now we can actually kind of blow through this SQL more quickly since, well, I did it earlier in the stream. I'm going to assume that I've basically got the same watch viewers right now. But so we already said how to do the start accounts. You select subscriptions where the subscription start date is less than the calculation start date. It's actually really terrible of me using the same name. This is actually poor programming style here. I should have called this like calculation start date and calculation end date or something like that to distinguish it from the subscription start date. So it's too bad I already published the book. There's no going back now, but this is what we got. So anyway, you find start accounts by comparing subscription dates to the date of interest, and the same thing for the end accounts. But now let's look at that churned account SQL. This is it, what I was just talking about. Select the accounts from start accounts, left outer join, end accounts on account ID, on the account ID, but then the key that I mentioned is where account ID is null. So let's go try this actually. Let's see, I had this run churn listing. This was like, I'm gonna say listing 2.1. Whoops, now I'm actually going to change it. I will duplicate this. I will make listing 2.2 easily just by changing this parameter. So this is, I imagine, what most people would do if they were following along with the code from the book. You would basically make configurations just by duplicating, changing the parameters. Now once again, I guess I'll just run it first, and then I'm going to take the printout SQL. It prints out the final SQL, and then I'll put that into the SQL program to inspect it. So this is the SQL running. It says running chapter 2, listing 2, churn rate on schema, blah blah blah. So I've already set my search path. So I'm gonna actually take this whole SQL, and we can go over to my not so trusty SQL UI program. Let's just try running it first and make sure it works. This is what I should have done last time. Run it first, make sure it works, and then start hacking it apart. So let's go back up to here and say, let's look at what we get in the churned accounts. So just like say limit 10 or something. Now we can actually look at the result in the churn accounts. Uh-oh. Oh god, this thing is dying on me again. Okay, there's my new statement. I think I need a new SQL editor. So here's the churned accounts. There's actually not that much, you can see. Let's see, maybe we should add a row. So I could add the ending e.account ID. And now here we should actually see that those are all null, right? Because I said where e.account ID is null. Now what would happen if I said not null here? Then I would actually be getting the retained accounts, because it's the left outer join, becomes like a right outer join if I drop out the rows that didn't match. But that's not what I want to do. So here I'm actually trying to do, the outer join where the ending account ID is null. And so that's how I get, the churned accounts here. And so that, I hope, illustrates, the behavior of the outer join. I can turn it around. Let's do the acquisition. If I do right outer join on the end accounts, where, let's see, now I'll say where start account ID is null. Now this becomes my retained accounts, actually. I have null on my start account IDs, and I have, an account ID on the end. So that is how this little churned account query works. Now, if you're, okay, once I heard that naming is one of the most important things in programming. Yeah, Rodrigo, nice. Yes, thank you. My naming was very bad on that SQL, and it is one of the most important things in writing self-documenting code. So do what I say, not what I do. Sorry for that. Okay, did I mention the database plugin for PyCharm? Works pretty well on my site. I should try the database plugin for PyCharm. One more thing. So, MustFit, you are clearly a PyCharm expert. He's been schooling me the whole stream on good plugins to use. So I should try that too, because like I said, I'm not really happy with this Postgres program. It crashed midstream, and that makes me look bad. I don't like, I don't like a program that crashes on me. Now, let's see. Have I beat to death this query? No, I think there's a little bit more beating it needs, which is going back, oops, and looking at the whole thing all together. Hey, thanks for the follow, Rahul Avero. Welcome to the Data Science stream. Happy to have you with us. Let me see. I'm trying to get back to this. So this was the original, right? I want to make sure I've got my original. Yes, this was my original query from the book. So I was showing you the churned accounts query, which is the key step of this, where we're doing the outer join, end accounts on start accounts, where end account ID is null. Now the rest of this is actually pretty simple. We just do the start count as select count from the start accounts, and then the churn count is select count churn account dot star as end churn from churn accounts. And I just do these two little count group bys to make the final select clearer. It's kind of complicated enough as it is. So now the final churn rate is the number that churned divided by the number at the start. Now that's also key, because remember, the churn rate is not supposed to be influenced by the customers that you added. It's not supposed to be influenced by the customers that you added during the time period, which again, going back to the illustrations, that was illustrated here, showing you that these two customers added don't affect the churn rate. And also, if you go back all the way to my, this diagram, or actually I should go forward to the next version. Considering this version, again, the churn rate is the churns relative to the customers at the start, and the acquisitions don't affect it. All right, so let's see. Back into this code. And so then here I also just show the number that started and the number that churned. Now, do you notice here that what's the churn rate? 6.7%. Wasn't that exactly the same thing that I got from net retention? Yeah, I think it was. This is churn rate and retention rate from my SQL. So what does that tell you about this simulated service? It tells you that everyone's paying the same thing. So let's go back and look at the, let's see, the net retention. I can prove it to you if I can get back to it. I don't know. Actually, it might not be worth it. All right, you just take my word for it. This was the same as, the net retention that we got. And that's because everyone in the simulation pays the same thing. So that's what you get when everyone pays the same. You could actually use the net retention, which is a little bit simpler calculation instead of the churn rate. But when do you want to use this churn rate? I call it the standard churn rate, so that makes it sound like it's the most common. And it actually is the most common definition for churn. So when do you use churn rate? So as I said, churn rate does not reflect upsell and downsell. Now that is actually a good thing. It's good to ignore those kind of price differences when you have temporary discounts to your customers. So let's say you give out a discount promotion and then later on, the discount expires, and that means those people's prices were going up. Now, if that happened and you were using net retention, it would reduce your apparent churn, but it wouldn't really be a reduction in churn, it would be the expiration of your discounts. So it's good to use the standard churn rate that I just showed you when you have discounts that might be expiring, or also, upsells and downsells, like I mentioned. So if you have a few prices that are not too far apart. Now, what do I mean by prices that are not too far apart? I mean, like, if your standard plan is like $10 and your premier plan is like $15, those are actually not that far apart. I mean, in the scheme of things. When using the standard churn rate is a problem is when you have a really wide range of prices, which is commonly the case for business-to-business products. So I'm talking about, $10 a month, $15 a month. What about products that are $10,000 a month or $100,000 a year? Then you're getting into a different territory. And I know this very well because my company Zora sells a business-to-business product like this. And I can tell you that our highest paying customers pay something like 100 times the lowest paying customers. So that's why I say if you have two prices like $10 a month and even $20 a month, those are kind of close together. Apply a log and everything gets fine. And we do apply logarithms in many cases for analyzing these B2B customers. B2B means business to business customers. So when you're analyzing business to customers, you do end up applying log transforms on the resulting data very frequently because you have customers over multiple orders of magnitude. Basically, you might have a startup paying, $10,000 a year, and then you might have a public company, a public enterprise company paying you $1 million a year. So there you have 100x difference between your high-paying and your low-paying customers. And in that case, does it make sense to use the standard churn rate? Actually, no, because then it's really, the standard churn rate equal weights all your customers regardless of what they're paying you. Now that's a bad thing when you have this really big difference between your high and low paying customers because it just it overstates the importance of your low customers. In that case, you want to use what we call revenue churn, which I think is what's coming next. All right, so we did customer churn standard, and next we talk about revenue churn. And that's what you use when you're concerned about having some customers that pay a lot more than others. Now, wasn't retention a revenue-based churn measure? Yes, the net retention we already looked at was a revenue-based churn measure, but that one, had the problem I mentioned of including upsells. Now, revenue churn is the strategy of calculating churn only looking at the negative. It's like the most pessimistic churn calculation you can make because you include the money you lose from people churning and the money you lose from people downselling, but you don't include the money from people upselling. So it's actually kind of like net retention, but more one-sided. I talked about how net retention includes upsells a lot. Net retention also includes downsells. So revenue churn is like net retention, but ignoring the upsells. And so that's the most pessimistic. Hey, Detox Mango. Love your screen name. Love a good mango when I'm detoxing. So let's look at a revenue churn toy problem. You said you used to work as a quant. Yeah, I used to work as a Wall Street quant in the good old days. Instead of downsell, shouldn't it be the delta? That's what I lost. Yeah, well, basically that's what you mean by the downsell. And let's look at the revenue churn toy problem right here. So now again, supposing we have our product that has 5 customers in the first month, 7 customers in the second month. We lose one churn. We gain one customer to a complete churn. So we had a $29.99 loss. And then suppose we have another customer that downsells from $29.99 to $9.99. And it looks like in my example, we have another customer, who upsells from $9.99 to $29.99. But in this case, for this churn measure, we only count the downsell amount, $20, for this customer 4 who downselled, and we count the churn amount, $29.99, for the customer who churned, divide that by the revenue at the start, and get the revenue churn, which is now in this case 56%, $49.99 over $89.95. Okay, Detox Mango question. I am curious, have you read the book Mathematics of Arbitrage or know the content covered in this book? No, it sounds interesting. I know basically what arbitrage is, in theory. I mean, an arbitrage, they say, it's basically an opportunity to buy low and sell high. And it's, like a perfect opportunity to buy low and sell high. And they call that like an arbitrage, when it's like built into the system that you can buy something at a low price and sell at a high price. I don't know exactly what that book is about, to be honest. And I'm not really I'm not like really a finance quant guy. Hey, there will be memes. That's a great screen name. Value MRR discrete. Yeah, values of MRR are going to be discrete. Well, depends what you mean by discrete. They're discrete in pennies. So the MRR is monthly recurring revenue. I should have labeled that better or put a slide on it. So the MRR is always going to be a whole amount of money. It's not going to have fractional cents, but you could have dollars and cents in it. And so, okay, standard, premium, not sub. So let's see. What did I study to land a job as a quant? That's another good question. I did a PhD in biophysics. Like many people who land jobs as quants, you do a PhD in something else, and then you decide that you don't want to do it. And if you know math, you stand a chance of getting a quant job. Although pretty tough interviews for quant jobs. Minimum standard, you can only get $9.99. Okay, there will be memes. I'm not quite sure what you mean. I mean, values of MRR, yeah, it's basically the standard plan MRR is $9.99, the premier plan is $29.99. In this made-up example. And for many products, your price points are fixed, like standard and premier and basic. You might have a basic plan. Although that's not actually the case for business software. In business software, there are practically no fixed prices because everything can be subject to negotiation. You have a list price for every business software, subscription plan. There's a list price, but then there's always negotiation. Depends on how many add-ons you buy, because typically business software is not single subscription. So that's the other thing about this. This is only showing one subscription per person. In typical business software scenario, you'll have multiple subscriptions for different extra features and allowances. They really kind of nickel dime you. Yours can get unhandy in case of multiple currencies. Yeah, well, I'm only working on single currency here. And yes, Detox Mango, I did work in risk management. I was doing risk analysis. So let's see. Let's get back to revenue churn and look at the code. So let's go to our revenue churn code, listing 2.4. Let's see. Here we go. And again, that means chapter 2, listing 4. And I think once again, I will run it with the wrapper program, and then I'm going to collect the printout. Let's see, once again, just going to duplicate my configuration, make a listing 2.4. I'm just putting this one. I'm skipping 3. Don't worry, we're going to come back to 3. That's going to be activity churn. But I'm starting to feel that activity churn might be a subject for the next stream. Detox Mango. This means that you have not read the paper Betting Against Beta. Let's see. I have not read the paper Betting Against Beta, although I certainly was very concerned with betas in my risk analytic role. We were all about calculating the betas, which for those of you who aren't into finance, oh God, it's how much your portfolio is exposed to certain influences. Like, let's say your portfolio is exposed to the price of oil and gas. Like, if oil goes up, your portfolio goes up. Then you have a beta. Anyway, so I don't know what betting against beta means, but I certainly spent a lot of time talking with, beta and alpha obsessed people back in those years. But that all ended for me like in 2014. I've been a data scientist and not a quant for a while. Yes, beta is basically a measure of correlation, and all we did as risk quants was think a lot about what's correlated to what and by how much, because that's your non-diversifiable risk. All right, so listing 2.4, I'll take the same strategy of just running it in PyCharm, and then I'm going to collect my output, and we can kind of hack on it in the SQL GUI. So here, as usual, when you run a listing from the book, it tells you what you're running. If it's SQL, it prints out the final SQL. Yeah, Rodrigo, capital asset pricing model. Yes, definitely related to that. Now I'm trying to remember. Oh God, I definitely used to know what the capital asset pricing model was, but don't quiz me on it now because it's been a while. That's the way it goes. You do different things at different times in your career, and it can get hard to remember. Oh wait, now I'm supposed to let's actually now see if the Postgres GUI will be cooperative, and we can now the thing about, here's the important thing in this query. Let's actually start looking at the parts of it, and we can step through them. Let me just make sure this runs. All right, still running and still basically giving the same answer, because again, everyone pays the same in this simulation. Oh, sent a question earlier. Take a look at it before you're out. Okay, a question in Whisper. Oh God, I'd have to get over. I don't even have. I can't look at it right now, but I'll definitely look at it later. Can you just tell me in the chat? Because I don't have actually Twitch open. So this churn query starts out the same as the others, and if you notice a pattern, I used the same components here. But we're again summing MRR, so I have all the accounts and all of their total monthly recurring revenue or payments at the start. And as usual, I do this with an inner join of the subscription on the start and end date, the poorly named start and end date for my calculation. The end accounts are also the same, but using the end date to pick out the subscriptions that are active at this time. All right, and then the churned accounts we get actually in exactly the same way as in the last churn query that we looked at, which was the standard churn. So here we have account, but we're also summing the MRR this time, which we did not do when we were doing standard churn. So now I've got all the churned accounts and the total payments, which is monthly recurring revenue of those that churned. And again, for those of you who missed it before, you do this using the left outer join trick of the start and end accounts. And now we take those where the start account ID is null. This looks like backwards. This is the churned accounts. Group by, oh no, we're at end account ID. Sorry, I'm misreading it. So you take those where the end account ID is null. And why are we doing a group by? Because accounts can have more than one subscription, possibly in the business context where there are multiple subscriptions typically. Some consumer products have multiple subscriptions and add-ons too. So let's see. So now the other key difference in the MRR churn case is we need the downsells. So now how do we know who has downselled? Actually, that's not so hard. So a downsell is an account that is retained but is paying you less than at the start. And now here we actually select out the downsell amount. And here it's the total MRR at the start minus the total MRR at the end. And that will give you the downsell amount. And and you only select those where the total MRR at the end is less than the total MRR at the start. So that's like a simple definition of what's a downsell. It's anyone who pays you less now than they paid you before. And some products, they have particular plans. Like if you have a 3-plan product, right, it's simple. If you have like basic, standard, and premier plans, you always know what's a downsell. Downsell is going from premier to standard or standard to basic. But again, in the business context where your customers can have many subscriptions and they might change subscriptions from period to period. So this is a more general definition of a downsell, just like anyone who's paying you less now than at the start. Now the problem actually is that running this SQL won't be that exciting because remember, in my simulation, everyone pays the same. I really need to make up a simulation where people pay different amounts, and that would actually make this stream a lot more fun. I'm gonna have to work on that. I never made a simulation where people pay different amounts, but it's actually doable. I should really work on that. Maybe for next week's stream, I could actually make a better demo of this because I could demonstrate this code for you, but I'll actually tell you there are no downsell accounts. I know there are no downsell accounts because everyone pays the same. Let's try it. Select in this simulation. Let's try it. See, no rows. There are churned accounts. Is it churn accounts or churn? It's churned accounts. So in this actual particular query, we've got churned accounts. We don't actually have downsell accounts. So that's kind of a lame thing about my simulation when I demonstrate this particular query, that there actually are not more than one MRR. So I think I might try to work on that. But that still, I mean, kind of gives you the idea of how this query works. Let's go back to the full version. So the full version, now illustrated here, is to, seems like a good business to me. Everyone pays the same. Well, this simulation isn't, it's not real. No one really pays for a social network. That's the other unrealistic thing about this. I say it's a simulated social network, but whoever paid $9.99 a month for a social network, they never actually implemented that, like a subscription plan for Facebook or anything. Anyway, so to finish this query, you have to select the downsell account and the downsell amount. And then again, I put in these sums, intermediate steps, selecting the total start MRR from the start accounts, the total churn MRR from the churn accounts, and then also add in the downsell MRR from the downsell accounts. And now finally, the MRR churn rate is the churn MRR plus the downsell MRR divided by the start MRR. And again, I should be able to just run this. Whoops. Oh no, I broke my query. Here's our line. What did I do? Can't leave well enough alone. Is that the error? There we go. So this is still just giving me the same churn rate as my regular one, 6.7%. And again, that's because in this simulation, everyone's really paying the same. And it also gives, well, you can see, like I said, there's actually 0 downsell MRR in this case. And you also notice I don't actually calculate a retention rate because no one actually talks about that really. Usually when you talk about MRR revenue churn, you just talk about the churn. And this is the churn plus downsell. And if you talk about revenue retention, it's usually for the case, like I said, where you want to you want to make yourself sound good, so you include the upsells. So if you want to make yourself sound good, include the upsells and use net retention. If you're really trying to understand how bad your churn is, only include downsells, and then you've got MRR churn. But no one reports MRR churn outside of their own organizations. It's really an internal statistic. And then the rosier sounding net retention is what you share, to the outside world. All right, so I am actually going to try to make a simulation with different MRRs so we can actually get some better examples of net retention and MRR churn. That'll have to be for me to do. Maybe I could do it in a stream. That might actually be fun. It would be really going into the weeds from the book. I'll think about that one too. All right, let's get back to the discussion, and I'll go through, 1025. Maybe we can do a little bit more before we call it a day. So let's see. Oh yeah, the law of churn versions. I need a better name for my law here. So if anyone comes up with a good name for this law, I'll give you bragging rights for naming the law of churn. Now this is the relationship between the three versions of churn that I showed in the stream today. Customer churn is higher than revenue churn, and that's higher than the net retention-based churn. Now why? This is actually really a thing for business-to-business companies. Customer churn is higher than revenue churn because big spenders churn less. Remember I talked about a business where, let's say you have some customers who pay you $10,000 a year and some who pay you $1 million a year. Well, the good news is the customers who pay you $1 million a year are going to churn less because they're bigger companies, they're more invested. A lot of reasons why big spenders churn less. So the equal weighted customer churn is actually going to be higher than your revenue churn, where you count all customers equally. So when you do revenue churn, you're actually counting your big customers more. But remember, your big customers churn less. So that's why revenue churn is generally going to be less than customer churn. Now, if you include upsells and you get net retention, yeah, Gold's law. I don't know. I think there's already a Gold's law in physics, but I don't think that, I don't think I can put my name on this. Could be Gold's churn law. Maybe if we include gold and churn, it could be something there. We can work on that. But anyway, so revenue churn is going to be greater than net retention churn because then you're adding in the upsells. So yeah, so those were that's kind of like the big picture on the three different versions of churn that we were talking about. And let's see, next we can do activity churn. And yeah, I think we'll try, actually I'm trying to wonder, should I keep going? I guess so. It's been just about an hour and a half. I'll just do the activity churn and then we'll call it a day and leave time period conversion, for another stream. All right, so let's go to activity churn and look at the basic idea to activity churn. So basically, you're just going to look at churn based on people who stopped using the product. And the problem with this, of course, is that people could stop using your product and then they could start up again. And that's kind of what's illustrated here. So we didn't really talk about events too much. I showed them to you at the very beginning of the stream. Remember, so we have these customer events. We can look in the event table. I think we're looking here. We have all these customer events, which are the individual actions people take on the service. Taking a little while to load, but they're point-in-time events per customer. So imagine these are all the customer events. Customer one, account one, and he's, customer, well, he has a lot of events. So if you imagine, this is what all of the customer's events look like on a timeline. Now, suppose someone takes a short break. This might be, say this is 1 week, this little space here. Well, we're not going to call that a churn because it's just a short break. But let's say this is like a 3-month break. Well, we might call them a churn after the first month that they're gone, or maybe the first 2 months that they're gone. Now for this, there's no rule, and it really depends on your product. But typically, people will define a window of like 2 to 3 months, whatever length of time, when usually if people go silent for that length of time, they usually don't come back. And so that is basically how you define it to detect a churn. So you'll say anyone, who's gone missing for too long is going to be called a churn. And then, well, here we go. We'll just go to the activity churn sequel, which is listing 2.3. Probability of churn in less activity. Well, right now we're just measuring the churn from the activity. And it's also definitely true that the less activity you observe, the higher probability of churn. But predicting the churn probabilities is going to be later. That starts in like later chapters of the book. This is just on calculating the rate of churn. And there's so many different ways to do it that I have a whole chapter of it. Okay, so back to this code. Now we'll do listing 2.3 by making a new configuration by copying the old one, listing 2.3. Say chapter 2, listing 3, and these parameters. And once again, I will first just run the SQL. This one actually takes a little while to run. Now this is a note here. This pause, this is actually the SQL running much more slowly than the regular churn SQL. Now why does this one run more slowly? Because here we're actually aggregating the events. And in the regular churn, okay, there it finished. It took 10, 15 seconds. The other ones were virtually instant because there we were aggregating the subscriptions. Now, a typical account only has one or a few subscriptions per month, but a typical account can have many, many events per month. So let's actually look at this SQL. Once again, I will just copy it out of this viewer and put it into the SQL GUI where we can mess around with it more. Let's first just make sure this works. And remember, this one takes a while, so I'll execute it again. But okay, it's working. So now, how is this one different than the others? First, I still start out by making a common table expression to find my start accounts, which is right here. So just select distinct account ID. But now what do I do to find them? I check if they have had any events within a time from my recent date. And so here you can see within my date range, my little common table expression of constant parameters at the top, I've added a 1 month inactivity interval. So for this churn calculation, I'm saying anyone who has gone silent for more than a month is going to be considered a churn. And so here, to find accounts active at the start, I find any account that has an event within the start date and the activity interview. So that's basically here. Event time has to be greater than the start date minus a month, and the event time has to be less than the start date itself. So that says all the accounts that are active at the start are all those who had events within the past month, as defined by my inactivity level. And then I count them. Now I do the same trick for the end accounts. Again, select accounts active at the end time. Their events have to have events within the inactivity interval before the end date up to the end date. And these are going to be the end accounts. So basic difference from the standard churn calculation is that we're calculating who's active and who's not with events. But now that we have the start and end accounts, the rest of the SQL is going to look very similar. We just select the churned accounts using the left outer join trick, which we went over earlier in the stream. So left outer joined, end accounts on start accounts, where end account ID is null. Let's see, and then we just count the churns. So actually the rest of the SQL all looks really the same as the standard churn SQL, and the only difference was when I was finding the start and end accounts was that I used the event data. So you notice this was a lot slower. So this is not something you would use if you actually have subscriptions. This is really just for the case of, well, not just, but it is for the case of ad-supported products, just like, any website or, I don't know, any streaming thing where it's ad-supported, but you're tracking your customers. You have to be able to track the customer events across sessions. That's actually key to this. You don't need subscriptions to do this activity-based churn, but you do need to track customers across multiple sessions in order to make this calculation possible. Because if you don't have all that event data, so the event data we collect is from multiple sessions, and that's how we do it. But so if you don't have subscriptions, but you can track your users or viewers over multiple sessions, then this is the churn calculation that you would use. So, okay, I think that's it on the revenue churn. Okay, the next subject is converting churn time periods, but I think I'm going to call it a day, actually. That was an hour-and-a-half stream. I think what I'm going to try to do is see if I can do a better simulation and get back into that other stuff later. All right, so for right now, I'm going to wrap it up. So thank you very much for being here with me today. I'm just going to summarize the stream. Fighting churn is about targeted interventions, which include improving your product, engaging with your customers, and supporting them. Churn compares lost customer and the amount they spend to starting customers and the amount they spend. Acquisitions are ignored for churn. Churn is easily calculated for big data using SQL, and that's what we were showing today. I actually never talked about why use SQL, and no one's really asked me about it. Like, why do you do this in SQL? Well, there's, I think, two reasons why it's good to do with SQL. One, the calculation scales to big data very easily. Assuming you have a data warehouse for your customers that's suitable size for your customers, you can do this in your data warehouse, and you don't have to worry if you have 100,000 or 1 million or 10 million customers. Your data warehouse will handle this for you with no fuss. The other good reason to use this is actually because you don't have to take the data out of your database. So it's an in-database calculation. So do you want to calculate churn by dumping all your customer data to a file and downloading it and then loading that file in Python? Now, that would be pretty ugly. You don't want to leave your customer data lying around in files. Remember, your customer data is very sensitive. You don't want to lose that data. You don't want anyone to steal it. So that's why it would be good to do this calculation in SQL. But yes, MOSFET, definitely, you could run this SQL into a dashboard like Tableau, Domo, Looker. There's so many BI tools. For those of you who don't know, a business intelligence tool. That's what Tableau is. So definitely a great way to do this in your company, assuming you do this for a company, would be to put this SQL in a dashboard in Tableau or Domo or Looker or whatever you got. QuickSight, how many BI tools are there? Okay, yeah, so that's actually like a third good reason to do it in SQL, is it's easy to put in a BI dashboard. All right, we also went over multiple measures of churn. Consumer products had standard churn, business products had revenue churn. If you want to report to investors, you use net retention because it's kind of like a positive glass half full, actually glass more than half full on net retention. And if you have ad or purchase supported products, you would use activity-based churn. Let's see, so there's summary. Actually, I need to get back and tell you more. Want to add that I have a new schedule now. Well, you probably already know it because you're here, but I stream Saturday mornings and Sunday afternoon. So my stream tomorrow afternoon is probably going to be pretty similar to this one. So I am not just like going to race on to more of the book. I still need to do that activity, the churn time conversions, and I want to get a bit more into some of the other stuff. Hopefully I can do a better simulation of the MRR. Okay, CET, no, I'm actually Pacific time. So I am this is showing you my time zone. Actually, you can see that, PSG. So CET, Central European Time, my Sunday stream will be very late. This is my only stream which is convenient for CET. But anyway, this is my schedule. Hope you can join me another time. It's been fun. And so yeah, thank you very much for coming to this stream today. You can connect with me on LinkedIn, follow me on Twitter. I'll give you all the updates about Churn, the stream, the other things I work on. And of course, glad to have you following me here on Twitch. And also the book, Fighting Churn With Data. This is all from a book, so if you feel like you need to read it, kind of look over it afterwards, please get the book. I'm showing here a discount code for 40% off, which I think my publisher still honors. I've been using that discount code for a while, but no one's told me it doesn't work. So if you try that discount code and it doesn't work, please let me know, but I'm just going to assume that's still active. So yeah, thanks so much for joining today. It's been great. This will be my next stream tomorrow. Peace. Have a good weekend. Good luck fighting churn, doing data science, whatever you do for the rest of the weekend. I'm going to actually go put up my Christmas decorations. That's what everyone's waiting for around here. We got to get Christmas decorations up, so that's what I'm off to. So enjoy the rest of your weekend. Happy streaming. Do your holiday shopping, whatever it is. Hope you enjoy it. Bye. I'm out.